Rationalizing denominators is the concept where you have some radical on the bottom of a fraction, but you don't want this to be a radical on the bottom, just because it becomes difficult to deal with, to be tractable. We really don't know what the number is on the bottom. So we can technically multiply by 1. We'll still end up at 1 over root 2, or whatever is equal to it. Now, clearly multiplying by just 1 is not helpful, but to rationalize something is to get rid of the root on the bottom. So I can represent 1 in a different way. I can represent it with root 2 times root 2. Root 2 over root 2 is still 1, so I'm still multiplying by 1. But when I multiply the fractions this way, root 2 times root 2 gives me the value of 2. On top, I end up with root 2. So what ends up happening is 1 over root 2 is actually the same as writing root 2 over 2. So we can look at some other versions of stuff like this. Another version could be, let's say we had 12 over root 2. Well, that didn't write that right. Hold on. Over root 2. Same idea. We want to multiply by a value of 1, and we want to rationalize the denominator. So we multiply by whatever radical the denominator is. In this case, root 2 times root 2 gives us 2. That works out nice. 12 times root 2, I can't really simplify, so I'm going to leave it like this. Now, when I write it like this as a fraction, this root 2, you can decompose this fraction, okay? This might be simpler to see. You might very quickly realize, hey, I can simplify 12 and 2 and write it as 6, or maybe that's visually difficult to see. And if it is, you can always do this. This is also equal to this concept, 12 over 2 times root 2 over 1. I've decomposed the fraction. The reason I decompose the fraction is so that it's a little simpler to see that, hey, I can actually simplify this fraction here. This turns out to be just the value of, where's my hand? There we go. 12 divided by 2 is 6. So I can rewrite that as 6, or 6 over 1, if we want to leave it as a fraction, still same thing, times root 2 over 1. That doesn't really change much. I really don't need that step. You might have been quick enough where you're like, I don't need this to be fractions anymore. This actually just ends up being 6 times root 2. Let's try another one. Let's say we're dealing with root 3 as a value, and we needed to divide by root 3 and times 6. So let's say we had 2 over root 3. Okay, same idea. Got to rationalize. Going to multiply by the radical on the bottom. So the fraction's still equal to 1. But when we go through the process, we rationalize that bottom. A root times root, they cancel out, and we get 3. And then on the top, we get 2 over root 3. I actually can't simplify that. That is my simplest form. I want to prove one quick thing to you. This root 3 times root 3 is actually an exponential law. We can represent the radical as actually a half exponent. Okay, technically there's a value of 2 there. So this is root 3 to the power of a half times 3 to the power of a half. And if you remember exponent laws, your bases, when they're the same, you can, if they're multiplied, you can just add your exponents, and that ends up being 3 to the power of 1, which is 3 in this case. Do one last one.
So every root will be like the same number?
Yeah, and that's the whole point. We're just making it so it's that actual number with no radical, no root over top of it.
Okay.
What was the one you were working with, the last one here? Was it 12 over root 3?
I think.
Yeah.
Yeah.
So let's say we had 12, just like we did 12 over 2. Let's do 12 over root 3. Same concept, multiplying by a factor of 1. And this rationalizes the denominator for us, so we end up with 3. Up here we have 12 over root 3. Now, it's very tempting to go root 3 and 3, I can do something here, but I cannot.
Yeah.
And without decomposing it, the question is, can we see what we can do maybe with the other numbers?
12 divided by 3.
Exactly. So 12 divided by 3 actually gives us the number 4. And we end up with 4 root 3 as the rationalized version of this number here. Let me take a look. So there's a lot of different ways we could have done that, but that's the process in a repetitive fashion.
Okay.